Chapter 2 is all about bad bugs. So these are all kind of wrapped into that one name, but we're talking about viruses, fungi, mold, bacteria, all the bad things that make us sick. So what are we looking at learning in this chapter? Identifying the major types of foodborne microorganisms, the bad bugs that make us sick. Describing the conditions that allow pathogens to grow. So we're going to be looking at Fat Tom. Recognizing the common foodborne illnesses and their prevention. So we need to know the common items which happen. So why does it matter? So pathogens are invisible. I can't see them. I can't necessarily tell. You may smell some foods or look at some foods and think, that doesn't look fresh, that doesn't look safe. But it can be that they may have been cross-contaminated. There may be no warning signs at all as to how toxic that food could possibly be. And just a few cells can multiply rapidly under the right conditions. That's what we're going to look at when we talk about Fat Tom. And managers must control time and temperature and hygiene to keep food safe. We can always control those three things in our kitchen. So let's look at the big six. These we've looked at before, but these are really important that you understand and remember these items. So we have Shigella. The SPP is species. So Shigella species, that comes from human feces. So we're talking about the fecal oral route when it comes to these. We're literally describing where someone has an illness related to Shigella. They went to the bathroom, they didn't wash their hands properly, they came back and they made you some food, and now you're getting sick. So shigellosis is the illness which comes from this. Hand washing, correct hand washing, and excluding those sick workers can stop this from occurring. Salmonella typhi. Now you may notice there's another salmonella right underneath this. So don't just think salmonella must be chicken. Salmonella typhi is only sourced in humans. Can you? No. Thanks. Salmonella typhi is only sourced in humans. It causes typhoid fever. You may remember from history classes and things like that. The typhoid fever, none of this is related to chickens at all or eggs at all. So we have to cook food properly and exclude any individuals who have been sick with typhoid fever or with Salmonella typhi. Non-typhoidal salmonella. This is the one that we're talking about. In poultry and in eggs. It can also be found in some vegetables as well. How can that be possible? So say if I'm using some chicken feces as fertilizer and it hasn't been properly treated before it's used, then that could leach into some food items, some vegetable food items that are grown in there. It could also be that if there's some runoff from a farm that isn't properly controlled, that could contaminate the soil and contaminate those food items as well. So non-typhoidal salmonella, find it in poultry and eggs, causes salmonellosis, and if you're cooking correctly and preventing cross-contamination, then we avoid a lot of these occurrences happening. Then we have E. coli or STEC, so that is Shiga toxin producing Escherichia coli. That's the fancy long Latin name for it, but E. coli or STEC is how it's very often named. This is found in cattle intestines. It causes hemorrhagic colitis. It's very uncomfortable. And so you must cook, especially things like ground beef, to prevent any cross-contamination from occurring where it could be from other sources. So this can also be found in things like vegetable products too. If there's some contamination that's coming from either using fertilizers, as in cow droppings being used as fertilizer that hasn't been properly heat treated or properly treated, or if you have some runoff from farms, from cattle farms as well, that can also cause some of these vegetable plants to be able to soak this up into them and then causing illness as well. So how does this develop, and how is it that cows aren't sick from E. coli? So cows have multiple stomachs. They have to be able to eat just grass and survive and thrive to become massive, 1.5, 2 ton animals. Well, how do they do that? Because if I went outside and just started eating grass today, in probably a few days from now, I'm going to be malnourished. In a couple of weeks, I'm going to be on the verge of death. Right? I can't just consume grass. It doesn't work that way for me, because human beings need more than just grass to survive. Cows have developed the ability, because they have multiple stomachs, so they actually use the ability to ferment that grass to be able to pull out and yield enough nutrients from that grass that not only do they survive, but they thrive and they get very big. So inside their stomachs, there's a lot of things going on in there, where we're literally starting to ferment products within those stomachs so that they can yield the nutrients from that grass. That means that there's a lot of bacterial growth going on in those stomachs. E. coli is very prevalent in that group of bacteria that are growing in there. Doesn't hurt the cow at all. They live in equilibrium with that. But when we come to eat the meat, if it's been contaminated with the E. coli, that could be a problem. So if I have a steak, if I have a whole cut of meat from that cow, even if it was contaminated during processing, when it was slaughtered and processed, the fact is the outside of that meat may have some E. coli on it. That's quite likely. But even if I just have a steak, I can sear it and sear it on the other side, and now the bacteria that's on the outside is dead. Because even if I'm having a rare steak, I'm searing the outside to put a nice crust on the outside. I'm killing all the bacteria off from the outside. The inside, there's very little bacteria. The main reason why we talk about ground beef as our big problem is because when we grind that same piece of meat, say if it was a piece of sirloin, if I'm grinding that same piece of meat that had the bacteria on the outside, I'm now grinding the bacteria inside. That's why we have problems. That's why it's not unusual. A lot of people will make themselves sick when they're grilling out. They'll be making burgers, and they're just getting the ground beef that they didn't grind, so it may have been ground a week ago, a month ago, a year ago. It's been possibly in a deep freeze in a grocery store company, and now it's brought out, and now there's bacteria ready to start enjoying themselves when you cook that burger just to a medium rare, and it's just basically warming up the bacteria that you've now ground inside that burger. That's why if you're having that burger, you should be correctly cooking it. What temperature do I have to cook ground beef to be safe? 155, exactly. Very good. All right, moving on. Hepatitis A. So this is also from the fecal-oral routes. So fecal contamination, someone not washing their hands properly when they are infected. How do I tell if someone has hepatitis? What are the symptoms that we start seeing? Right, jaundice. We start seeing yellowing in the eyes, yellowing around the gills, yellowing under the fingernails. That's when someone's liver is in trouble. Now, they probably have been sick for weeks before then. They didn't necessarily know what it was. So by the time we get to this stage where we do know exactly what it is, now we've got problems. We're going to get more into detail on the tracing of that and how we look out for things like that as well. But if you're suffering with hepatitis A, you must get urgent medical care to take care of that. Personal hygiene and approved sources, purchasing foods and shellfish from approved sources is a key way of avoiding this. If you source your mussels, if you source your mussels from a non-reputable supplier, Billy goes and knocks at the back of the door. Hey, got some cheap mussels going. Ooh, okay, sure. What if those were sourced from an area where, unfortunately, there was a sewage outlet that just dumped out because it was overwhelmed with rainwater, and now all of those mussels have been soaking up the raw sewage. They love it. They'll thrive on it. But they'll now have that hepatitis that could be in some of that raw sewage. And now that contamination can be coming your way when we eat those mussels up as well. So then moving on to norovirus, the most prevalent, the most likely reason why you are sick. So things are coming out both ends, kind of explosively. You're very uncomfortable. You end up becoming very, very dehydrated and very sick. So again, it's the fecal-oral route where you get sick with this. So you may have heard about some of the cruise ships. In general, cruise ships do an incredible job of maintaining sanitization around the ships because otherwise people would be getting sick on them all the time. You've got thousands of people on some of these ships all crammed into one space for maybe a week or so at a time. So it's very easy to spread things around. Well, all it takes, though, is to have one or two people who are sick with it come on board. You know, when you go along to the buffets, you go through the buffet line and you're scooping things out. The food's perfectly safe. They've done an outstanding job making tasty food that's safe. You scoop it out, scoop it out, scoop it out as you go down the buffet line. You get to the end, you grab a bread roll with your hands, and then you sit down to eat. You're pulling that bread roll apart, put some butter on there, licking your fingers. You are licking every single spoon handle that you just handled, and that all it takes is for that one person who had the norovirus, and you just lick their hands too. And then you wonder why you get sick. And maybe about 12, 24 hours later, you're feeling like you want to die. Right? So, and the lethal thing with norovirus can be is you get so dehydrated, you end up needing to be hospitalized because you can't even drink water. Everything just keeps coming out. So, this is a really significant problem, but making sure that we're abiding by correct sanitization of things, good hygiene, and excluding anybody who has vomiting and diarrhea. You don't want them near your food at all. Okay, so let's talk about how do bacteria love to grow. They love to grow with all the things we know about Fat Tom. So we have food, acidity, time, temperature, oxygen, and moisture. So when we look at food, carbs and proteins, those are their most preferred items to enjoy because they're kind of like us. Always remember that. Whenever you get questions on bacteria, they're kind of like us. They love to eat carbs and protein. They enjoy a neutral to slightly acidic environment. So from 4.6 to 7.5 is their zone that they enjoy being in. So meaning that just like us, if I'm jumping in the bath, I don't want a bath of acidity. I don't want a bath of alkalinity either. It can be very damaging to my skin. For these single-celled bacteria, all that needs to happen is to damage that outer layer, the cell membrane on the outside there, and they'll be toast in no time at all. So if they can't be in an environment that's super acidic or super alkaline, they like to be fairly neutral. Then we have time and temperature, the two T's, the two things we can always control. In every situation, we can always control those. So in terms of time, in the perfect Fat Tom conditions, bacteria will multiply every 20 minutes. They'll double every 20 minutes. So if there's 1 million now, in 20 minutes it's 4 million. In 40 minutes it's 8 million. Right? Everything all of a sudden can start just multiplying out rapidly. And then the temperature danger zone. So two sets of numbers to remember. The main temperature danger zone is 41 to 135, but the optimal temperature danger zone 70 to 125, right? So that's where we really need to avoid any food sitting for too long. Remember, when we start cooling foods, we'll talk about that later, but when we're cooling foods, that's the part that we do most rapidly. We don't want anything sitting in that optimal part of the temperature danger zone. Then we have oxygen. So for a lot of bacteria, they like oxygen, just like me. I love oxygen. But the fact is there are a few which are anaerobic, meaning that they do not require, in fact, they require an absence of oxygen to thrive. So where can I find an absence of oxygen? Canned foods, right? Yep, right, reduced oxygen packaging, right, where we've got vacuum-packed foods, any of those kinds of situations, that's where those anaerobic bacteria love to be. We'll talk more about them in a little while as well. But yeah, so canned products, reduced oxygen packaging, or even if I've got a big stock pot full of some kind of a soup or something like that, in the very center of that, there might not be much in the way of oxygen in there either. But other bacteria do enjoy oxygen. And then moisture, the water activity. So that's the available water. Just in the same way that if I'm sitting on a boat in the middle of the Atlantic, then none of that water is useful for me. I can't drink it because I'll die. So bacteria do not like to be in a situation where the water isn't available to them either. So if it's brine, if it's got a lot of salt in it, or if there's a lot of sugar, they can't, by osmosis, they cannot absorb that water efficiently. and so that means that they can't survive. So it doesn't just have to be dry food, but it can be. Right? If I've got rice or beans or pasta and they're all bone dry and not cooked, then that's great because I don't have to keep them in the fridge. But as soon as I boil them and add that water content back in there, now there's available water and food and neutrality in terms of acidity. All the things start falling in line, right? Or if I go and take other things like pork products that we very often will add lots of salt to them to cure them, then that all of a sudden just reduces down the bacteria's ability to grow on there because the water availability or the water activity is no longer there, okay? So overall temperature controls. So this just sums up all of our overall temperature controls. So if I'm keeping if I'm holding food, so not just cooking, maybe something like chicken, I must cook that to 165, right? But I'm talking about now maybe taking that chicken that I cooked to 165. Now if I'm gonna cold hold it, then I've got to cool it back down and get it below 41, right? So 41 or below, and then if I'm hot holding it, some chicken fingers on a buffet, then I've got to hot hold them 135 or above. If I'm cooling foods, then I'm cooling them from 135 to 70, right? Right inside there, we've got the most dangerous part of the temperature danger zone. That's got to happen in 2 hours or less. And then from 70 down to refrigerator temperature, 41 or below, now I've got to do that in a further 4 hours or less. If I'm reheating foods, I should do it rapidly. And I should be doing that up to 165. And I should make sure that that hits 165 so that no matter what may have gotten in there, or the fact that it's now gone through the temperature danger zone 3 times, right? Because if I'm cooking, cooling, and reheating, it's now gone through the temperature danger zone 3 times, there's more risk involved, okay? So that's why I have to reheat those to 165.
Would it matter that it went through 3 times if they had that last kill step?
No, it's still perfectly safe. That's a great question, right? So does it matter if it goes through those 3 steps? No, we do it all the time, right? We'll cook foods in advance because it's convenient for us, especially if you have a restaurant, so that we can cook it and then cool it. Now it's only going to take a short amount of time just to reheat it, especially if it's something that takes a while to cook in the first place. I don't want to be baking a baked potato on the fly when a customer walks in. Because if that jumbo baked potato is going to take an hour to cook, they'll be mad by the time they get that potato, right? But what I can do, I can cook them, cool them, and then reheat them. They don't take as long to reheat. So a lot of things like that can be done. It's perfectly fine. Then we just have to really worry as chefs about food quality. But yeah, as long as we hit 165, we're perfectly safe. So yep. All right, let's look at some of the characteristics of our bacteria. So they need fat tom to multiply, right? If I have too much acidity, or if I make it too cold or too hot, or if I do something with fat tom where I take it off the charts to where it's no longer comfortable for the bacteria, then that means that they will not grow and thrive. But if we have all of the fat tom conditions perfect, they will. So some of them form spores. Some bacteria form spores. A spore is basically where they take their DNA and their RNA and they maintain that to stop that from cooking, if I'm cooking food, or to stop them from freezing to death, or anything like that. They will form a spore around their molecular structure, so that way they're safe. It's basically like a shell, like a protective shell that they grow around themselves, so that way when you've got them boiling in that pot of chili for 2 hours and they're bubbling away, they're just bubbling away in that spore and they're protected. And then as soon as you start to cool it down and it hits the temperature danger zone, they can shed that spore, they can come right back to life again. Okay, so spore-forming bacteria are especially tricky to deal with. So you've got Clostridium perfringens, Clostridium botulinum, Bacillus aureus as well. We're going to look at those in a few minutes. But these are ones that we have to be especially careful of at times as well. So we're working to destroy these bacteria with cooking, or at least controlling their numbers. If they do form spores, then I might not be able to boil them out of existence. But I may be able to do it where I just control the numbers with cooling and reheating efficiently so that they're never comfortable. So when we're looking at bacteria in terms of our big six, then we're looking at Salmonella typhi and non-typhoidal salmonella that we already noted down. Those are our bacteria that are in our big six that we keep a special eye on because those are most prevalent. So let's look at our spore-forming bacteria. So we have Clostridium perfringens. So that one is, and this one, these can be noted in the exam. Any of these items can be noted in there, but just remember, these are not part of the big six. The big six are the ones that we concentrate most on because they are the most prevalent illnesses we get out there. But with Clostridium perfringens, the typical setting we'll find them in is on large roasts, stews, and gravies that we cook. So what goes wrong? If we are slow to properly cooling them down, as in they're sitting in maybe the most dangerous part of the temperature danger zone, you think about if you have a large rib roast, it might take a couple of hours for it to actually cook that to where you need it to be. It might take more than that to cool it down. That's part of the problem because it's such a dense, solid piece of meat. It might be very difficult to actually cool down properly and efficiently. So the primary control is to cool things rapidly, reheat them, and hold them per the code. So reheating things like that roast back up to 165 if I'm reheating it. Bacillus cereus. This is the one that we find in cooked rice and pasta. So while that rice is dry or while that pasta is dry, then no problems. Because remember, in fact, Tom, you've got to have that. You've got to have the available moisture or the water activity for the bacteria to grow. There's no water, they just sit there, but these are spore forming, so they can sit there for a long time. If everything dries up, if they're in an arid situation where there's no moisture at all, they just form a spore around themselves and they just sit and wait, sit and wait, sit and wait for a long time. And so that's why when we cook that rice or cook that pasta, we don't just leave it sitting out. We cool it efficiently if we're not using it immediately, and we treat it as though it's any other TCS food like meats. And so warm holding that, at the correct temperature is okay, but at the wrong temperature, if it's just kept warm, that's a significant problem. So we should be holding it at 41 or below, or hot holding it at 135 or above. Okay? Then Clostridium botulinum. So this is the one that we see most likely to be with reduced oxygen packaging, like cans and vacuum-packed foods. And when they have been time and temperature abused. So this can be a significant problem. If you have enough Clostridium botulinum to fit on the head of a needle, the head of a pin, can kill you. When I first started hearing about people getting Botox injections, like in their forehead and things, to look good, I was like, "Are you kidding me? Clostridium botulinum?" Now it's a product which has been altered so that it's not going to kill you. But the fact is, there's a reason why it freezes your forehead. It's because that's what it can do to the rest of you as well, right? So this is a lethal toxin that's produced by Clostridium botulinum, and you really don't want to be consuming foods that have this. So if you see cans which are incorrectly canned, say if they're bulging, if they're damaged, if they're pierced, anything like that, you definitely don't want to be taking in any of those kinds of things. If you are using reduced oxygen packaged foods, so say things like fish, when you purchase that fish, you should not be leaving when you're slacking off the fish ready to cook and you're allowing it to defrost. Then you should be taking it out of that packaging so that oxygen can get to it. Because if it's Clostridium botulinum, it requires an absence of oxygen. If I give it oxygen, it stops it growing. Okay, so understanding where it's coming from as well. But Clostridium botulinum is also a spore-forming bacteria, just like the other two on here. And if they're put in a conditions where it's extremely cold for a long time, or if it's extremely hot, then they will still survive. They'll form that spore around themselves, and they'll just shed that spore off when they're ready. Viruses do not grow in food. They need humans or an animal host to actually start to pull in nutrients from. So they are the smallest pathogens, easily spread via hands and surfaces, and water as well. They're resistant to temperature and sanitizers as well. So when it comes to hepatitis A and noroviruses, these are some of the most prevalent. Well, norovirus is the most prevalent. Hepatitis A is quite lethal. We need to make sure that we are maintaining cleanliness, and when we have individuals who are sick in our team, that we don't allow them contact with our food. Parasites. So they live inside animals, inside a host, and they're transmitted by undercooked meats or contaminated water. Parasites can be particularly nasty. One of the easiest ways I can avoid having parasites getting in and causing any kinds of problems is that I purchase from approved, reputable suppliers. So in this country, we're very lucky. We have very few parasites that tend to be in our foods, but we have to still be careful and guard against them. But purchasing from approved, reputable suppliers, we should be fine. And sometimes, in some things, we may have to freeze. So if you've got some things like tuna, or if we're getting some wild game, we'd actually freeze those to kill off any parasites that are in the meat of those items as well. Fungi. So molds and yeasts, some can spoil foods, others can produce toxins. And so we should be discarding any moldy food unless the product is meant to be mold, like ripened with cheeses, like the cheeses we tasted earlier this year. Those ones where we actually use molds to help us to produce great flavors. Aflatoxin found in peanuts, and then beneficial yeasts are a couple of examples that we have here as well. So toxins in general. So we have some natural toxins that we find in fish and some plants. Chemicals like cleaners and metals that react especially to acids. They can't be destroyed by cooking or freezing. Toxins are toxins. They'll be there all the way through with that food item until someone consumes it or it's discarded. So key ways to prevent it: source and control and the segregation of chemicals, making sure that you don't have any chemicals nearby, and then always using approved, reputable suppliers. So we have things like histamine, which is also called scrumbotoxin. So that is found when you have some seafood that was not purchased from an approved, reputable supplier that was time and temperature abused. And then we have sugarterotoxin, which is also found in other seafoods. This is when you have larger seafood items which will go swimming around and they'll start eating other smaller fish that already have that sugarterotoxin in them. Doesn't hurt that larger fish. They start building it up in their fat cells, and when we come then and fish them out of the ocean and eat them, then we get sick. And then we also have things like wild mushrooms. You know, some of those really innocent looking white mushrooms that will grow outside your house on a rainy day like today. Those are some of the most toxic mushrooms we have in this country. Don't let your dog get out and start eating them. They can get really sick with those. But there's lots of wild mushrooms out there that look perfectly innocent, and they'll make you very sick. So cross-contamination control is key. Separating raw and ready-to-eat foods, cleaning and sanitizing between tasks that we do, and then having color-coded equipment like our cutting boards, knives, so that way we can tell what it was last used for. So hopefully we're always washing, rinsing, sanitizing properly, but that way we're minimizing how much possibility of cross-contamination. All right, let's do some questions. Which condition supports the growth of most bacteria? Is it a pH level of 2.0, it's pretty acidic, or available water of 0.6, or the temperature between 41 and 135, or D, completely frozen? C, absolutely, yeah, that temperature danger zone, perfect for bacteria. A cook who fails to wash hands after using the restroom could transmit what? Norovirus, E. coli, listeria, or sugar toxin? A, norovirus, yes, exactly. That's the most likely one that a food service worker is going to transmit. What is the best way to control the growth of bacteria? Store food at the correct temperature, increase moisture, reduce acidity, or add sugar? Absolutely, yep. Storing the food at the correct temperature is always going to win. A toxin mediated infection results from what? Chemicals entering the food, bacteria producing toxins inside the person, virus destroying the liver cells, or the parasite eggs in meat. So meat toxin mediated infection results from, so it's not chemicals.
Where it doesn't say meat.
It's B. So a toxin mediated infection results from bacteria producing toxins inside the person. Right, if I'm going to be eating the food that has bacteria in it, then they start producing all sorts of toxins inside my gut, then I get sick. So what's a manager's role? Is to purchase from approved, reputable suppliers, train the staff on time and temperature control, have monitoring logs and keep those monitoring logs so we're maintaining it, and then calibrating thermometers so that we know that the temperature that we're measuring is correct, and then enforcing the exclusion of ill staff so that we don't have anyone making our food toxic. So we've looked at biological hazards causing the most foodborne illness, controlling growth using our Fat Tom knowledge, preventing cross-contamination and time and temperature abuse are key, and then using suppliers that are approved and hygiene stop the bad bugs. Any questions?
I